All right, hi 8th grade. We are on lesson 2, session 2, performing a reflection on the coordinate plane. Okay, so do you remember when I was saying things about how the line of reflection, so in this case it's the y-axis, or it could be the x-axis, I'm sure. Let's just say it's the y-axis. I haven't read the directions yet. But you want your points to be equally spaced from the line of reflection. So for example, if this was the line of reflection, x is 1 point away, so x prime would be 1 point away over here. W is 1, 2, 3, so w prime would be 1, 2, 3 points over here. Okay? So that's how you do a reflection over a line of reflection. Let's read the directions. Alyssa is making a paper dragon puppet as part of her family's Chinese New Year celebration. She lays her tissue paper over the coordinate plane, then she draws figure WXYZ for one of the dragon's eyes to make the other. She reflects WXYZ across the x-axis. Ooh, that's important information. We are using the x-axis as our line of reflection. I'm going to go ahead and highlight the x-axis. The x-axis is our line of reflection, not the y. So she reflects it across the x-axis to form the image WXYZ prime. What are the coordinates of the vertices of WXYZ prime? Yay, so fun. Okay, so let's start with y. Y is one space away from the line of reflection, so y prime will be one space away from the line of reflection. Y prime. Okay, x is 1, 2, 3, 4 spaces away, so it's going to be 1, 2, 3, 4 spaces away, x prime. W is 1, 2, 3, 4, so it'll be 1, 2, 3, 4. And there's w prime. And then z is 1, 2, 3, so we'll go 1, 2, 3. And there's z prime. Now I'm going to grab my eraser, and I'm going to erase all my little jumps. That way we can see our shape a lot easier. Oops, it erased my line of reflection. That's okay, we can get rid of our line of reflection because we know it's the x-axis. Get rid of my line of reflection. Okay, now I'm going to take my pen and I'm going to go ahead and connect these points. All right, and there you go. There is WXYZ prime. Now we're not done yet. It says, what is the new coordinates of the vertices of WXYZ prime? So let's start with W prime. And then we'll do X prime, Y prime, and Z prime. Okay, W prime. Remember, we go on the x-axis first. We are going backwards 1, 2, 3. So if we go backwards, that means it's negative. And then we are going down 1, 2, 3, 4. So if we're going down, that means we're also going negative. So the new coordinates of W prime is -3, -4. All right, let's keep solving them. Let's go look at X. I'm gonna use a different color so my jumps don't confuse me. Back 1, down 1, 2, 3, 4. So it's going to be -1, -4. Y, do green this time, is back 1, 2. So that's going to be a -2. And then it is down 1, -1. Looks like all of these are going to be negative because they're in the negative coordinate plane. All right, now let's go do Z. I'll use green again for Z. 1, 2, 3, 4. So back 4 means -4. And then we're going to go down 1, 2, 3, -3. All right, there are the new coordinates for my reflected picture. Just remember, on a coordinate plane, if there's a shape in this coordinate plane, those will always be positive, positive coordinates. You will always have positive coordinates. If it's in this coordinate plane, oops, it'll always be negative, negative coordinates, just like we had. All of our coordinates were negative. Over here it will be negative, positive, and over here will be positive, comma, negative. We'll talk more about that in class together. All right, let's go to the next page. Over here, it is just explaining pretty much what we did. Okay, so what I want you to remember is to just count how many spaces it is to the line of reflection, and then count how many spaces it's got to go from that other side, okay? We're not going to worry about the model it too much. The picture it shows what we did. The model it is showing you how the coordinates really didn't change. It was more like the negatives that changed. So if you see, the original W was at -3, 4. New prime W was at -3, -4. So I can see that the Y coordinate just changed to be negative. There's some really cool patterns you guys will be able to find with reflecting and translating. All right, look at the picture it, which is right over here. How does the distance of each vertex of WXYZ to the line of reflection compare to the distance of its corresponding vertex of prime WXYZ to the line of reflection? Basically what that question is asking is the fact that we counted how many spaces we had to go to the line of reflection, and then we counted that many spaces to get our new point, okay? So what we can say, we're just going to try to explain that in the most simplest way possible. We're going to say each vertex, remember a vertex is the point, each vertex of the image is the same distance from the line of reflection as the corresponding vertex of the original picture, okay? We're going to try to say that in less words as possible. Each vertex of the original image, oh right, images are the copies, I forget. Image is the copies. So we're going to say each vertex of the image is the same distance to the line of reflection as the original image. All right, number 2. Look at model it, which is right here. What are the coordinates for the vertices y prime and z prime? Complete the table. Okay, so it wants us to go put these in here. Remember how I said that the only thing that changed was they made the y coordinates negative? So it would be -2, -1, and -4, -3. And that's just because we went from this coordinate to this one, okay, where everything's negative. So that's why just the y coordinate changed. Okay, I'm going to put a little check mark. We did it. The table shows the coordinates of a point change when it is reflected across either the x or the y axis. Describe how the coordinates of a point change when it reflects across each axis. Okay, so what it's saying is notice that if it reflects across the x-axis, the x changes. So, okay, so here's the original, 2, 3. If it were to reflect across the x-axis, do you see how the y changes into a negative? To the blue, positive right down there. And if it is a negative, it changes to a positive, okay? So I'm going to say this. If a figure reflects across, oops, not 2 C's, the x-axis, then the y-coordinate changes to the opposite of what it is. So for example, if it's -3, it would change to +3. If it's -3, it would change to +3, and if it was +3, it would change to -3. So if a figure reflects across the x-axis, then the y-coordinate will change to its opposite. I'm going to say opposite sign, because the opposite sign of 6 is -6. Now we can say the same thing with the x-axis, except for it's backwards. If a figure reflects across the y-axis, then the x-coordinate will change to its opposite sign. Sorry, my handwriting is so awful, you guys. It's really getting squished in here. I'm going to zoom in. Period. Okay, and you can tell because look over here at this graph. Look at the pink. If the original flipped across the y-axis, do you see how now the x-axis is what changes? Okay, it changes to its opposite. So if it was -1, now it's 1. Okay, so flipping is actually super easy if you know the original coordinates. Even if you don't have the original coordinates, you can go backwards super easily just because you know if it reflects across the x, the y's will change. If you reflect across the y, then the x's will change. What are the coordinates of the point xy when it is reflected across the x-axis? Okay, so if I reflect x comma y, they're both positive, right? And I reflect it across the x-axis, that means y will change to its opposite. So it will then go and be x comma -y. The second half of the question says, when it is reflected across the x-axis, okay, so this is if it's x-axis. I should have wrote this smaller. Hold on, let me erase. We're gonna run out of room real quick. Okay, so if it's x-axis, flipped, my coordinates x comma y would be changed to x comma -y. Remember, it's opposites. So if it flips the x-axis, then the y's change. If it flips the y-axis, then the x's change. So here's the original. And it would become -x comma y. Explain why only one of the coordinates would change when you reflect a point across an axis. Now, I want to explain that in class with you guys when I can show you it in person. So remind me that that's something we're going to talk about in class. So in class, we'll talk about why is it that only one of the coordinates change to their opposites when you reflect, okay? So remind me, that's what we're going to do. Number 5. Think about all the models and strategies we have discussed today. Describe how one of them helped you better understand how to solve the triad. Okay, so what that question is saying is, when we made this new image down here, was it easier for you to understand when Mrs. Ringler just jumped all the jumps and made the new image and then just made the new coordinates? Or was it easier for you to understand when we talked about how the x's and the y's change to their opposite just because of the way that the coordinate plane is? Okay, so explain to me, which one do you prefer? Do you prefer to draw it out yourself, counting the jumps and then finding the coordinates? Or do you like thinking of it more mathematically where you know that some are going to be negative, some are going to be positive? Okay? All right, last page. Number 6. Seth reflects the triangle ABC across the x-axis. to form triangle DEF. Draw DEF. What are the coordinates? Okay, so I'm going to go ahead and do that. We're going to reflect it across the x-axis, so this is our line of reflection. Let's start with vertex A. Vertex A goes 1, 2, so it's going to go 1, 2. B goes 1, 2, so it's going to go 1, 2. And C goes 1, 2, 3, 4, so it will go 1, 2, 3, 4. I'm going to erase my jumps. That way we can make our triangle nice. Okay, now we have DEF. Now I have to make sure I label DEF correctly. I can't just say DEF, okay? And here's the reason why. They have to correspond to ABC. So they have to match up, okay? So A and D have to correspond. So this would be D. B would be E. And then C would be F. You can't just go ahead and just willy-nilly label it. You have to make sure they correspond. Now we have to go find out what the new coordinates are. So D, E, and F. Let's go find out. So D, we go over 1 and up 2. E is over 1, 2, 3. Up 1, 2, 3, 4. And then F is over 1, 2, 3, and then up 2. Okay, since it's in coordinate 1, everything is positive. We did it correctly. Let's look at number 7. Isabel is planning a design that uses different colored wooden triangles. She starts by drawing triangle JKL in the coordinate plane. Then she reflects JKL across the x-axis to form JKL prime. Draw JKL prime in the coordinate plane. What are the coordinates of the vertices of JKL prime? So we're going to do exactly what we just did up here, okay? I'm going to count the vertices, 1, 2, 1, 2. See how we are reflecting across the x-axis? So let's do K, 1, 2, 3, 4, 1, 2, 3, 4. So that is K prime. Sorry, I didn't label this one. This is J prime. Now look at X for a second. Let me erase my jumps. X is already on the y-axis. If it's on the y-axis, or the x-axis, and the x-axis is the line of reflection, that means it's not going to move. Okay, so this is X prime. So X and X prime share the same coordinate. All right, so now let's go ahead and do J prime, K prime, and L prime. Okay, so J prime is down. Oh wait, so we go left and right first. Okay, do we go left and right at all? No, so it's 0. No left and right, but we go down 2, so -2. K is over 1, 2, 3, 4, but then we go down 1, 2, 3, 4. So it's 4, -4. And then X stays the exact same. So we go over 1, 2, 3, 4. And then do I go up and down any? No, so it's going to be a 0. And there's the coordinates for JKL prime. Ooh, I can already tell what number 8 wants us to do without even reading it. And the reason why I know that is because they did not give us a picture. What I think they're going to have us do is they're going to have us use the logic of this table to find the coordinates without actually drawing it. And that's okay, we can do that. Malik draws the quadrilateral STUV in the coordinate plane. S is this, T is that, U is that, and V is that. Then Malik reflects the quadrilateral STUV across the y-axis. That's super important to know. To form the new prime quadrilateral. What are the coordinates of the vertices of the new prime quadrilateral? Now, remember, you can solve this without having to draw it on the coordinate plane, because we know something. if it reflects across the x-axis, that means the y-coordinate will change. I'm going to say changes, but it means goes to the opposite, okay? If it reflects across the y-axis, that means the x-coordinate will change to its opposite. Okay, so remember those rules. Let's go ahead and write it over here. S prime, T prime, U prime, V prime. Okay, I'll make my parentheses. Now, which one is it? It flipped on the x-axis, so we're going to use the x-axis rule, which says the x-coordinate change. So y-axis rule says x-coordinate change. The x-coordinate is the very first coordinate, and we are going to just change that to its opposite. So, for example, S, original S, was -5, -4. That means if the x-coordinate changes to its opposite, it's going to be +5, -4. Remember, this guy stays the same. This guy changes to its opposite, okay? So then T would be +4, -1. U would be +1, 0. And V would be +3, -3. These rules are super, super important for you to memorize, okay? And it only works with reflections. Okay, that means we will do these pages together in class. Bring any questions you have so that we can answer them together. All right, bye guys.